All right, counting sig figs. We'll use, I think this is the way that you guys probably learned it freshman year, the Atlantic and Pacific. All right, what we're looking here is we're looking at the decimal point. Is the decimal point absent or is the decimal point present? We're going to start counting with the first non-zero digit. Don't worry, we're going to go through a bunch of examples. And 3, we're going to count until we run out of things to count. All right, so let's look at our first example here. 1,000. First off, number 1, is the decimal point absent or present? I know the decimal point should be here. It's not here. That means it's absent. So if we think of the United States, the Atlantic Ocean is on the right-hand side. So we're going to start from the right. We're going to start counting with our first non-zero digit. All right, our first digit is a 0. That is not a non-zero digit, so we're going to skip it. Skip it, skip it. This one right here, we're going to start counting with this one until we run out of things to count. Well, we just counted that 1. So for this first number, 1,000, we have 1 sig fig. Only that 1 out front there is significant. All right, the next one, 100.0. So again, Atlantic or Pacific, the decimal point is present. We have a decimal point right here. So we're going to start on the Pacific side, the left-hand side. We're going to start with our first number. Is this a non-zero number? Yes, it is, number 1. So now we're going to count everything after that as significant. So we have 1, 2, 3, 4 sig figs in our second example there. Let's look at our third example. 0.1000. All right, absent or present? It's present. So we're going to start on the left-hand side. Is 0 a non-zero number? Nope. So we're going to skip that. So we're going to start up. 1 is. So anything after the 1 is significant. This one also has 4 sig figs. All right, a couple more examples here. Decimal point is present. So we start on the left-hand side. We hit a first non-zero number. We're going to skip the first 0, second 0, third 0. Oh, we hit the number 4. That's a non-zero digit. So now anything after that is significant. So here we have 3 sig figs. Oops, I don't know what's going on with my pointer there. All right, there we go. So next up, 450. The decimal point is absent. So we start on the right-hand side. 0, we're not going to count it. 5, anything after that is significant. So now we have 2 sig figs. All right, the last one here. Uh-oh. Scientific notation. Scientific notation is the best way to figure out sig figs, because any number that's written in scientific notation is significant. So this one, since we have 4.00, that is 3 sig figs. All right, a couple more. How many? I'll give you guys, why don't you guys pause this, write down your answers. When you're ready to come back, hit play. All right, the first one, 100. Decimal point is absent. We start on the Atlantic side. We hit a non-zero number, 1 sig fig. Second example, the decimal point is present, so we start on the Pacific side. We hit a non-zero number, 3 and 4, 2 sig figs. Decimal point present, left side. First number is a non-zero number. Anything after that is significant. So all of these are significant. 6 sig figs. Here, we have the decimal point present, start on the left. We hit a non-zero number, the 6. Anything after that, significant. 4 sig figs. All right, our fifth example, decimal point is absent, so we start on the right-hand side. We hit a non-zero number. We hit the 9. Anything after that is significant. So 4 sig figs. And the last one should be really easy for us. It's written in scientific notation. So there's 3 sig figs because, again, any numbers that we write before the times 10 is significant. A little scenario number 1 here. A group of civil engineers were at a conference being held in Central Australia. As part of the conference entertainment, they were taken on a tour of the famous rock Uluru. This rock, announced the guide, is 50 million 4 years old. The engineers were astounded. They couldn't believe that they knew the age of that rock down to the however many. There's what's that, 1, 2, 8 significant figures there. So they asked, how do you know the age of the rock so precisely? Easy, said the tour guide. When I first came here, they told me it was 50 million years old, and I've been working here for 4 years now. That does not mean that rock is 50 million 4 years old. All right, we're going to talk a little bit now about how do we treat these numbers when we add them and subtract them, multiply and divide them. There's two sets of rules. There's addition and subtraction rules. For addition and subtraction, we only consider the number of digits to the right of the decimal. Basically, the least precise number. All right, your answers must have the same amount of digits to the right of the decimal as the number in the problem that had the least. So let's look at an example here. We look here, our first number goes out to the 10th spot. That's the most accurate that it, or the most precise that it gets. Our second number has a number in the tenths, the hundredths, even into the thousandths place. So next, we come over here. This one goes out to the 10th thousandths place. So what is our least precise number, our number with the fewest digits to the right of the decimal? This first number right here. So basically what we're going to do is we're going to chop off anything at that point. So right here, we're going to round this number, or we're going to get rid of this stuff, and we're going to round this just to be 6.2. A way that I think about that, you guys can look at it. Let's say we had 2.0156. Is stack them up and do the math like you used to do in grade school. So this way, it's very easy for us to see which is the least precise number. We can just draw this line on the outside of the 2.2. So now when we did add all this up, 6.2186, now we know where to round. We can round that off. Again, if this number to the right of the 2 is a 5 or greater, we would round it up to 6.3. All right, second example here, we're doing some subtraction. So here we see our numbers go out to the hundredths for our first number, but only to the 10th spot for our second number. We don't round anything off yet. We still plug it in our calculators, we get an answer, and after we've gotten our answer, that's when we round off. Again, this 9 is greater than 5, so we round this up to 22.6. All right, so we have 0.12 plus 1.945 plus 2. We see the 2 only has a number in the 1 spot, so we're going to round off here, get rid of that to just be 4. Last one. We have 3 numbers to the right of the decimal, 3 numbers to the right of the decimal, only 2. So we calculate our answer, and then we round it off so that we have 2 numbers to the right of the decimal. All right, so that's for addition and subtraction.